Good morning. Today I'm going to do a simple schematic for an alarm that should be used in our fridge door or even in freezers. I'm going to do the schematic very quickly using KiCAD EDA, and that's how you open your KiCAD. This is how it looks. And if you want to create a new project, you go to File, you open New Project. And then I had done it before, but I want to do it afresh. So what I'll do, I'll go back here in my articles, in my new articles, and I'll create a new folder, and I'll name it fridge do alarm. Then I'll open it. Then I'll save my file as the alarm schematic. That's all. You save. And you have here, you start a schematic. This is the interface. So I'll set my schematic very quickly. In my schematic, we have the place where to place your components. And this is one of the places where you place your components. You can start shortcut key A, where you place your components. Let them load. Like this, and then you start placing your component. My first component will be 9 volts positive. I place it like that. I place A. Second component will be resistor 10K. So I'll have a resistor, but I want to use another symbol. I want to use the American symbol. So you can search in for resistor like that. Then you go down here, you have the US small. Okay, you place it. These one are connected. The other symbol you control S to save. The other symbol is the LDR. So take the LDR symbol 07. I use 07. Okay, place it like that. You connect it. W for wire. Connect it. Control C. Then I will place the ground. Escape A. Ground. GND. You place it like that. You can go as you connect most of them. Wire. You connect. This one is not connected. Not connected again. Like that. Control C. You can increase the by zooming in and out to make it more visible. So the next component is a diode. The diode, which is 1N400 it's a multi-purpose diode. You want to rotate it, and you press R is the shortcut for rotation. Then the diode is connected wire to this point. Control C. Then we place our first timer, which is the 555 timer. But the first timer that I'm using is MEPD. This one. Okay. We place it like that. You connect this one to 2 wire like this. And then 4, you copy this 9 here. Copy. You power this part like that. You copy it again, you place it at an 8. The 8 here should be powered again like that. Control save. From there we have 2 connected to 6. So you can move from here like that. You connect it to 6 like that. Control save. We have our first capacitor, and in this capacitor, of course, it's an electrolytic capacitor which is polarized. Therefore you place it again. So you come to capacitor, copy. Sorry. So these are unpolarized. You want to take the polarized, but I want to use the American symbol. So you come like this and you place it there. Then you change the value by placing V. This one is 47 microfarad. Place OK. Again, the resistor we never input our value, so you can change it. We said it's 10k, like that. And then now we connect this U. This capacitor is connected here from here to this point. Sorry. So you come here. You are here. You input wire, and then you connect. That one is connected. The capacitor is connected to the ground, so you can copy this by placing C. Like that. But again, that one is wrong. So you copy. You have to connect with a wire. Like that. And then from there, we have 3 going to a resistor of 10k again, 100k. So you come to copy this resistor. You place it there. Now you can move it by pressing M. Move. So you connect this capacitor. Then you can edit the value of V, which is now 100k. You see it like that. Then it is interconnected to another capacitor of 470. So you can copy this one again and paste. Then the value, which is now 170. What is it? Where do we get it? 470k. Like that. You can place it as OK. Then you can interconnect it from here to this point. From this point, it goes this way. Then from 3 like that. We are good to go. So far so good. Very nicely. So we go to the next bit of the connector, which is another IC 555 timer. So you copy this one, then you place it. You place it like that, and then you realize that these 3 is connected to the phone. You control save. And then we have ground here. You can copy in ground this one. You can copy. You ground it again here. Then of course 2 to 6 is interconnected. Like that. Control save. Now from there again we have to power the systems. So powering them, you come here to copy power. You power this system through pin 8 like that, and you have to input a capacitor, but the type of capacitor now you are inputting is different. It's not polarized, so capacitor. So the type of capacitor we should be using is not, it's unpolarized, so you can take it like that and you place it there. It is interconnected from here, so you can take wire like that, and then you copy ground and you bring it here. You place it like that and control save. So you move to the next bit, which is now the resistor. 470 resistor is here. We can copy it directly and place it there. Place it somewhere there. This one is interconnected there like that. That's number 3, and then 6 moves from here to that point. We can control save. Then we go to the next bit, which is another resistor 100. You copy this one. You place R to rotate it like that. You connect it, and then you change the value to 100. Press enter. Then from there you move to a buzzer. So you have to place component, which is a buzzer like that. You pick it, you come to this bit, you place rotate R to rotate it. You can rotate it the way you want, so you want it to look like that, and then we connect this R wire to that bit. Control save. Then we ground, so you can copy this one. We ground this one like that. You can control save. and then we have to use an LED, which is very important in this instance. So we have to use our LED. Our LED. So you can come again to place component, then LED. Okay. So our LED, you can rotate it to suit this situation. So LED should look like that. Then you come to wire, you connect this thing like that, and then you ground the LED. You copy this ground, you move it there, then you ground it, the LED. Correct. Control save. This is how our schematic looks like. But there are some of the pins that are not important, so you can close them like that, close them like that, close them like that. Then you can control save. So after placing our component, the next, this is how our schematic will work. This is the sensor, and this is the board of the sensor. So you come to this bit whereby you have to annotate the schematic for it to have components. You see the component by in question mark. So you can close it. Already it's annotated now. We have this one as U1, this one is U2. Then you go to check, you go to electrical rules check. You can run the system. You can see there is some pins that need to be checked. Those are errors. So this pin, then we have another one. Where is it? And this one. So what you do, you come to you search for something called a power flag. So this one, you pick it there, you come and place rotate, place it there, then you copy it, then you come and place it here again, then you control save. Then check on the power again, you run, you can see finished. For power it's correct. You go to the next bit, which is addition of footprints to the system. So you want to add some footprints to our schematic. Before we go proceed to the next bit of it, so let it load. It's taking a bit some time. So footprints will give our schematic 3D symbols. So it's very important to add some footprints anytime you're doing a PCB design before you proceed to PCB layout. Okay, it's taking some time, but it's about to be done. So you have to wait for it to do it. Okay, that's correct. So we can start with our buzzer. We have the buzzer here, beep pump. So we can check on it, the type of the buzzer we want to use. We come here. You can check the 3D of this buzzer. Okay, come here, check, watch the 3D. This is how our buzzer will look like. So for me, this one is okay. So you can add it as a footprint. Then we go to capacitor. You come to capacitor. We want to use SMD capacitors, and then we want to use electrolytic. You don't need to check for the symbol. I've shown you how to check it. Then you go to capacitor 2. Again SMD. But now I will use a different type of capacitor. Different type of capacitor. So I'll use a different type of capacitor. So for the capacitor, let me check which one I will use. Work on SMD. So I can try to check on SMD. So we have so many types of SMD capacitors. I will use 1206. This one. As our next capacitor. Diode is already has a footprint, so you leave it like that. You go to LED, you search here, you go to L, it will take you to LED SMD. Then in our LED, we shall be using 120636. Now for the LED, I can use the THT one. correct? So this one, I'll use this one. Let me check for the symbol with the arm contended with it, and not a bad one, so I can use this one. Then we go to resistors. You come here, you search for R resistors. You can see they are here, the SMD resistors, and of course I'm going to use the 12, this one. So that one is okay. 12. And then these all are added footprints. You press apply, then click OK. After that one, you can generate your BOM if need be, but for now we are not generating the BOM, so I'll proceed to the next level, which is now generation of the netlist, which will help us on the other side when it comes to generation of our GABA files and so on. So you proceed to the next level, which is PCB layout. Now we are in the place of PCB layout. You come to update schematic, you check at it, you update. We have total warning 0, errors 0, like that. Then you close, you bring your updated schematic there like that. Then you expand it. You expand it. So we have our schematic, it's like this. We have all the tracks, nothing is, the layout has not been done, and the routing has not been done. We have to check it, so we can come to 3D view, and then we see how our schematic will look like. This is how our schematic will look like, but now we have to arrange everything in order. And to arrange everything in order, you start by this one, you move it like that. That's our buzzer. Okay, that's our buzzer. This is our LED. LED and buzzers, they move together, so you can move it. Our LED is somewhere there. You can come and pick this one is the first IC. You can move it. You place it somewhere there. You can pick your second IC. You move it. You can place it somewhere there. Then you can take our RDR. You can move it. It is supposed to be somewhere here, like that. Yes. Then we have our diode, R1, C1. You can move our C1, move, so it's closer to the R1, like that. Then we have our R1, we move it, it's supposed to be there. We can rotate it to this one. R1 and R2, they were together, is R2. We have our R3 move, which is supposed to be somewhere here. Then we have our R4. So we have this one, move. This is our dial. I'll place it somewhere there. You can move it. So it is supposed to be somewhere here. Move R100. Move. This one is supposed to be somewhere here, so we can rotate R. Correct. Then we have our LED, which is there. This one can move. Then this one you can also move a bit. So we can try to press the parts together. So you can move this one. It's all connect. So you can come back to the schematic and try to edit something. So you have this power, there's no connector, but it's okay. So in this schematic, we can try to add something, which is our connector. So you can come press M, and then you come to COM. We want to edit something that we forgot. In this con we can come, we have 01, 02, 01 times 02. like that. This connector, you press OK, then you come here, then you can copy the ground, you place it there, like that wire, like that. Then you can copy the power, you place it there, then you come to wire, you connect it like that. Control save. You will go back to the other process we had done. You annotate, you close, you go to check the electrical connections, finished, you close, then you update your netlist, you generate it, close, and then after there you can come and do what? You update your PCB, you update your netlist, update. With errors occurred during the netlist updates, you fix them. So there is I have not added some footprints, so you can come back here to the schematic like this, then you add footprints. Yep. You add some footprints there. That circuit cannot work without a footprint being added, and therefore you have to do it. So you come to connectors. So for connectors, you can try to check which best suits your functions, whatever you are trying to do. So I have this one, I can pick on this one for now. So okay, this is a good connector for this system. Right now you can come here, I can use that as my connector. Okay, so I can control save, come to netlist. Now you can update the netlist, save, then you go now back to schematic. Then on schematic you can update it. Then you can check, update, save, close, you bring it there, like that. And then now you come to view, the 3D view. Where is it? The view or the 3D viewer. You can see now, you have something, we have tried to do something, the arrangement and so on, but I want to change again this arrangement a bit. I want to change it a bit. You can move this one. So we can move this one, move like that. We can move this one like that. We can move this one like that. Then we can move this one like that. Then we can move. Then we can control save. Then you can check again the 3D view. We see how the arrangement looks like. You see, it's pretty good. It's gaining shape. So again, you can try to move this one, move a bit balanced, and I can check again the 3D viewer. We see what we have. Not bad off. So we can go to routing. Now we can start routing our PCB. And before we start routing, you have to check for some few updates here and there. So routing starts like this. You come and check for the track size here. You can change it, but for now I'll be watching with that one. It's okay for me. So you start your routing. You start your routing process. You start your routing process. So routing will be done very fast. So you can go like this. You go like this. You can go like that. You can go like this. So routing should be done very nicely. Routing should be done very nicely. Routing should be done very nicely. So for example, this one, you cannot go like that all that way. That one will be a very funny. copper routing. So you can come here and place V to place a V. Then you can go to the bottom line like that. Now after going to the bottom line, of course you have to follow the rules again. The rules like that. You have to follow the rules. Then you place V again. So whatever this V will agree to be, that is the point it should be. Then you come and finish up. You can see. So we have gone to the bottom layer and made our track, and then come back to the PCB. So this is how everything should be done. You see, like this one again, you don't have, you can, there is no way you can, so you have to place a V like that there. Then you continue like that. To the point of focus like that. Then you place V again. You have a V there, you can place it. Then you finish up the track like that. Track like that. Control save. You go to the next one like this one. This one is very simple here. You go to the next routing part like that, simple there. You go to the next one. So this one you have to place a V there. Then you go like that with the bottom layer to that point. To that point, you come with a V. Like that. Then you finish up like that. Control save. You go like that, like that, like that until all the parts have been routed. All these parts must be routed. All these parts must be routed. All these parts, all of them must be routed. All of them, all of them, all of them. All these parts. Routing must be done in all these parts. Wherever you want to place a V, you place it. You continue with the journey. Again V, you place it where it is agreeing to be placed. Then you finish up like that. You control save. All of this, you can see again here you have to place a V. So V, then you can have another V there where it's getting. Then you finish up. Control save. So you need to do you need to do the you need to ensure that you do. Yes. You ensure that all the routings have been done. Then you can add some edge cut, which will define the size of your PCB. And this one is done like this. So you can activate this one to help you measure the grid to the point where you want to make sure that you have your like that. You make sure it is straight up. You go down. Again, you ensure it is very straight like that. Then you go back to this side. Then you finish up. That's all. That's all. Then you come here, try to check out the review. You see what is happening. Your system, you can see some routing have been done. You can check the routing in the bottom layer, as the system is now almost ready. So you can come and try to now do some copper powering to define some layers here, like that. Before you do that, you go to copper layer, then you come to click here now, like that. So you check on ground, you click OK, come to this end. We will see what will be happening. We will see what will be happening with our system. So you come to this other edge, you do this, and then you go and close it. You see what is happening. It's now isolating the layers the way they're supposed to be done. So you come to the next layer, again, you do the same. Our PCB is now gaining shape. Again, ground, you click OK. So we want to isolate the ground, for the power from the ground. That's all we're trying to do when doing this. So you can forgive us if we're not doing it very quickly for you. So you can see what is happening. You can control save. Then you can check and come to view, 3D viewer. Then we view at our circuit. Add. Now you can see our circuit, how it looks. We have layers, the ground isolated from the power. You can see everything now. And this is how to do a PCB design. And the PCB design you are doing specifically is a fridge sensor. And this will be telling the user of the fridge whether the door is closed or it's open, because it has a buzzer that will be giving some sound at the end of everything. So this PCB, you can change the color of this PCB. You can come to preferences, you can choose color. For example, you can decide to change the body color, and you can take different colors. You can decide to take green as the body color, and then you click OK. You can see the body color is changing to green. You can change the color of any other view. You can come to preference again. You can choose color. You can change the color of the solder mask. You can change it to red, for example. You click OK, and then you can see the color has changed. That's quite simple. Then apart from this one, you can generate some files, design files. You can come to fabrication output. All these are the files that you should generate for it to be complete, and share it with your favorite manufacturer. So if you take the BM file, for example, you can take it and then you can save it. That one is downloaded. And then you GABA files, you plot. For GABA files, which are the most important, you plot. You come to plot, check here, all the layers have been ticked, then you plot. That's how it's done. Then you generate. You can generate also the drill files. Yes, generate the drill files, generate them up. Then you close, and then you close again. Everything is generated. You zip it and share it with your manufacturer. And that's how our fridge door sensor can be fabricated through PCB KiCAD, electronic design automation tool. Thank you.